Welcome back to Inquisitive Kids. In this chapter, we will be learning about symmetry. And this is lesson 1 of our chapter, and it's going to be Introduction to Symmetry. In this chapter, we're going to be learning about multiple things. First, what is symmetry? And then we're going to be learning some geometry. So, isosceles triangles, perpendicular bisectors, angle bisectors, and so on. Our learning goals for today is to be able to identify symmetry in everyday life and be able to understand the concept of symmetry and be able to find the axis of symmetry in figures. I want you to observe these images. As you can see, they are all photos taken at a lake or a river, and you can see that the water is very clear. So the image you see above the water is basically the exact same as the one reflected in the pool. And I'm sure you've all heard of symmetry at least once before in your life, and you know that it's when both sides of a line is equal. For example, when I was in kindergarten and I was learning how to cut out a heart, I would first fold my piece of paper in half and draw half of a heart like this on the side of the paper that was facing me, and then I would start cutting. And then when you take your piece of cutted paper out and you unfold it, you get a perfect heart that is even on both sides. Here are some more images. This is the Forbidden City in China. This is the United States Congress. This is the Eiffel Tower, and this is the Taj Mahal in India. These are all very famous landmarks, and they all have symmetry to them. And these images are the red patterns that you cut out usually during Chinese New Year or a Chinese festival. And most of these intricate pictures are made when you fold a piece of paper over and over again, and then you cut it in a specific way. When you unfold your piece of paper, you are left with an image like this. So what do these pictures all have in common? Here's our introduction. These are all symmetrical figures. If a 2D figure is folded along a straight line and either side of the line coincide with each other, then this figure is a symmetric figure. The line would be its axis of symmetry. We'll see what this means as we go deeper into the lesson. So as you can see, line A is the axis or line of symmetry for this first image. And when you fold one side of this line to the other side, you can see that both halves fully overlap with each other. And it's the same with the butterfly. In this case, the axis of symmetry or the line of symmetry is horizontal. Which of the following are symmetric figures? So here, this Olympic sign would be symmetric, and B is not symmetric, but the dragonfly is actually symmetric. It's just that in this case, its line of symmetry would be diagonal. Can you give some examples of symmetric figures? Well, for example, very simple. A computer is usually symmetric. This building, I don't recognize what it is, but it's also symmetric. So is this, and so again is this dragonfly. Find the axis of symmetry in each of the following figures and try to find which figure has the most axis of symmetries. So here are all our figures. We have 7 in total. For this rectangle, we have 2 axes of symmetry, one horizontal, one vertical. It's the same for this rhombus. For the square, we also have diagonals. For the circle, we actually have an infinite number of axes of symmetry. It's just that in this case, we only listed out a few. If you think about it, all of the radiuses are the axes of symmetry for a circle, and there is an infinite number of radiuses you can draw out on a circle. For this triangle, it's an isosceles triangle. It has 1 axis of symmetry. This is an equilateral triangle, and it has 3. This is a hexagon. Think about it. What do the following figures have in common? When you fold this image across this line, you get a symmetrical figure. And this point is point A. This point is A prime. This point, if you think about it, let's say that this point is point P. CP is equal to PC prime. If you say that this point is H, this is O, and this is O prime, then OH would equal HO prime. And when you say that this point is E, for example, AE would equal EA prime. So their distances are the same because they are reflected across this axis. If the figure coincides with another figure when folded along a straight line, then the two figures are symmetrical about this line, and this line is their axis of symmetry. Which of the following groups of figures are symmetric? So for this first one, we can see we have two identical butterfly drawings, but they are not symmetric because they aren't reflected across this line. For B, it's actually symmetric. This might be confusing for some of you viewers, and I don't blame you guys, but I think they are trying to show that this is symmetrical. C is not symmetric, and D is. I want you to compare and contrast. For example, this figure, this butterfly figure, has axial symmetry, which means that it has a axis of symmetry in it. And this is actually a mirrored image. I hope you can find the differences between these two figures. A mirrored image is you take an image and then you draw a line, and then you have to reflect this image across the line. Of course, these are all having to do with symmetry. The difference is that this figure has an axis of symmetry within itself already. Yet, in the mirror image, two congruent figures are reflected across an axis. So they both overlap when folded along a straight line, and they are both symmetrical, but they are symmetrical in different ways.